Hi guys, so today we're going to look at the graphs for the square root and cube root parent functions. Okay, so the transformations that we do are going to be very similar to what you saw earlier in the year. What's going to be different though is that we're going to look at two new parent functions. So the first one is the square root parent function, which is just the square root of x. Okay, if you forget what this function looks like, it's a good idea to plug in points. So if I plug in 0, the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. All right. Now, this graph is going to look a little bit different because I am not going to have any negative values on my parent function because we cannot take the square root of a negative number. So this graph is going to have actually a clear start and stop point. Now, the domain on this graph also is going to look a little bit different, because the farthest to the left we can go is 0, because again, we cannot take the square root of a negative number. Now, as we do some transformations, the domain and range will change, but the domain will be restricted on these graphs. The cube root parent function is going to look somewhat similar, but the biggest difference is that with a cube root, we're still going to have 0, 0, we're still going to have 1, 1. An easy x value to pick for cube root, though, is going to be 8, because the cube root of 8 is 2. That's a value that we know. What's also different about cube root is that you can take the cube root of a negative number. So I get -1, -1, and -8, -2, also on my parent function. So that's going to change the shape of my graph a little bit. So my graph is going to look like this. All right. So again, this one, from about here over, it looks pretty similar to your square root graph. It's just a little bit flatter because it takes longer to get to those points. But again, this graph will have a domain and range that's -infinity to infinity. All right, so those are your two new parent functions. It's really important that you guys know those. Now, the next part is our transformations. Now, these are going to be very similar. We'll talk about that later. These are going to be very similar to what you guys have already done. Now, the information in the box, that's your generic parent functions, okay? This is going to be very, very similar to what you did with absolute value, what you did with quadratics, the same types of transformations, okay? If it is inside the parentheses near the x, those are our horizontal changes. All right, if it is outside the parentheses and away from our x, those are our vertical changes. And remember, your horizontal stuff is backwards. So -h is actually going to the right. And then on our stretches and compressions, if a is greater than 1, that's actually going to compress it horizontally. Whereas if a is a is in between 0 and 1, that is going to stretch your graph horizontally. The other thing that's new for these parent functions is the reflection over the y-axis, because until this point it hasn't really mattered if you've reflected over the y-axis, because the absolute value graph would still look the same, the quadratic graph would still look the same. But when it comes to a square root, it actually is going to make a difference if you reflect it over the y. Okay, so what we're going to do is we're going to look at these transformations just on an actual square root or cube root graph. So I made some of these square root and some of them cube root. It would translate the same. So x minus h would go to the right by h. X plus h inside would go to the left h. So again, if it's inside the root, it's going to go horizontally. If it's outside the root, then those are my vertical changes. So that would be down k and that would be up k. All right, again, outside is going to be vertical. So if a is greater than 1, then that is a vertical stretch. If a is in between 0 and 1, then that is a vertical compression. That will affect our y-coordinates. If it's inside, again, it's backwards. So this is still a stretch or compression, but if it is greater than 1, that is a horizontal compression. And if a is in between 0 and 1, so those are numbers like 1/2, 3/4, 2/5, those would be our horizontal stretch. And if you remember that Desmos that we did in class, that really kind of demonstrated this really well for you guys. So when it was a horizontal stretch, that point was moving away from the x-axis, which was stretching it out horizontally. Okay, when a was greater than 1, it was bringing that point closer to the x-axis, or closer to the y-axis. Again, if you want to see a visual of this, I would go back to that Desmos activity we did in class. There's a link on Schoology. All right, and then our reflection. So these two get mixed up quite a bit. So the negative on the outside, okay, it's away from the x, so it's a vertical change. If you're changing your graph vertically, then it would reflect up and down over the x-axis. So this is a reflection over the x-axis. Right? Whereas this one down here, this is going to be a reflection over the y-axis because it's going to change it left and right. So instead of your graph going this way, your square root graph would go that way. All right, so these are your basic transformations. Okay, so to start, we're just going to look at some square root and cube root graphs, and we're just going to list what those transformations are. So on A, this graph would go, if it's x plus 2, inside the root is horizontal, so that would go left 2. Outside the root is vertical, so that would go down 4. Right? Inside the root's horizontal, so this would go right 3. Outside the root is vertical, so this would be a stretch by 2. And this would be a reflection up and down, which is over the x. All right, and then on this last one, minus 6 outside the parentheses is vertical, minus 2 inside the parentheses is horizontal. And remember, your horizontal stuff is backwards. So this is going to reflect over the y. It is also going to be a horizontal compression. Okay, it's going to be a compression by 1/2. All right, then this graph also would go down 6. All right, so let's look at some examples and let's actually draw our graph. All right, so the first thing we need to identify, first of all, is it square root or cube root, so we know what our parent function looks like. All right, so this one is square root. Then let's look at our transformations. This graph is going to go to the right one. It's going to have a vertical stretch by 2, and it's going to go up 3. All right, so the first thing I'm going to do is I'm going to plot my starting point. So typically your square root parent function has this general shape, and it starts at 0, 0. So instead of starting at 0, 0, I'm going to go right 1 up 3, and I'm going to start here. Now from this point, there's a couple different ways that you can graph this. One is you can completely transform your original point. Okay, so my original point is 1, 1. Okay, but what's being changed here, it's going to go right 1. Okay, so now that point is going to be at 2 because it's going to the right. I'm also going to stretch this by 2, and I'm going to go up 3. So what we have to remember, though, if we're doing it this way, is that our order is going to matter. Okay, so what I would do here then is I'm going to multiply by my 2 first. So I would do 1 times 2. Then I would add 3. So my new point now is at 2, 5. Right? Another thing you can do if you're not sure is to plug in a point. Okay? Plugging in a point and making a table will always give you accurate graphs. Now, being familiar with your transformations and parent functions will make this a little bit faster, but if you're not sure, you can always pick a point. We just need to be careful that we pick easy points to find. So for example, if I plug in 2, all right, the square root of 2 minus 1 is 1, so this is 2 times 1 plus 3, which is 5. So again, 2, 5 is on my graph. Right? The last way that we can use to find this point is we can look at our transformations in relation to that center point. Okay, so normally my first point on the parent function, okay, after 0, 0, I usually go to the right 1 and up 1 to get to my second point. Well, what's going to change due to this transformation is now it's being multiplied by 2. So now, instead of going right 1 and up 1, I'm going to go right 1 and up 2 from my starting point. Again, that puts me at the same point. But again, this is in relation to my start. Okay? So whatever method works best for you, just continue to use that method. All right, so I'm going to go ahead and find our second point. So I'm going to do a table of values. okay, this time. All right, and again, I want to pick a value of x that's going to be easy to find. So like if I picked 3, I don't know the square root of 2, so that's not going to be a good point to pick. So a point that I'm going to want to pick instead would be 5, because this would be 2 times the square root of 5 minus 1 plus 3. So this would give me 2 times 2 plus 3. So 1, 2, 3, 4, 5. 5, 7. And then if I want another point, an easy point to plug in would be, let's see, if I wanted the square root of 9, okay, I could plug in 10. So this would be 2 times the square root of 10 minus 1 plus 3. So that would be 2 times 3, so 6 plus 3, which would be 9. And there's your graph. All right. Again, domain and range on these square root graphs is going to be a little bit different. So this graph does have a definitive start and end. So I am going to have a hard bracket on this side. So it's going to go from 1 to infinity. My range does have a low point, which is 3. It does touch 3, so it is a square bracket, and then it keeps going to infinity. All right, so now let's look at B. Okay, first thing we're going to do is we're going to list our transformations. This graph is going up 3, and it has a reflection and a vertical stretch. So a vertical stretch by 2, reflect over the x, because it's up and down, and then it's going to go up 3. All right, this is a cube root graph, so my typical function is going to look like this, but again, it's going to be reflected and stretched. So I'm going to plot my starting point, which is up 3. All right, so then from here, what I'm going to do, I can look at, let's look at our transformations. Okay, so I'm going to actually transform the points that are on my parent function. So I already did 0, 0. So normally this graph goes through 1, 1. Okay, but our transformations here, vertical stretch by 2, reflect over the x, and up 3. Okay, so what that's going to do my graph is it's going to take my y coordinate, and I am going to multiply by a negative 2, and then add 3. So 1 times negative 2 plus 3. We'll put this point at 1, 1. All right, then if I did, let's say, negative 1, okay, I would negative 1 typically goes through negative 1. I would multiply by negative 2 plus 1, which puts me at, whoops, wrong button. Which puts me, sorry, I'm adding 3, which puts me at negative 1, 5. All right, and if we want to see another point, typically I go through 8, 2. But again, transformations here, I would multiply by negative 2, then I would add 3, which puts me at negative 1. And then just one more point just to make it a little easier to see. So negative 8, negative 2, multiply by negative 2, add 3, so I'm at negative 8, 7. And I missed my points on my graph, but there is your graph. And again, knowing your transformations, you can see what's happened here, okay? This graph has been stretched by 2, it has been reflected over the x, and then we also have shifted it up 3. And then domain and range for these cube roots should hopefully be pretty simple. Negative infinity to infinity for all of our cube roots. All right, so let's look at one more. So this one's probably one of the most missed ones because of that negative on the inside. So that negative on the inside is going to reflect over the y-axis. But because of that negative on the inside, that graph actually is not going to go to the left 2 like you're used to seeing. This graph is actually going to go to the right 2. Okay, because if you think about it, if you actually take what's inside that root, if you set that equal to 0, then I would get that negative x is equal to negative 2. But I don't want negative x, I want positive x. So x is actually equal to a positive 2. So this graph is actually going to get moved to the right. Okay? Because now, again, if I plugged in 2 for x, that would give me 0, which is that starting point. So 2, 0 is my starting point. All right? So again, on this one, you can pick a table of values. You can transform your original points, whichever one's going to be easier for you. I'm going to go ahead and transform my original points. So my original point was 1, 1. All right, but what's going to be different this time, we're not even going to change our y coordinate at all. What's only going to change is going to be our x coordinate. All right, so our x coordinate, so this graph is reflected over the y, which is going to change our x, and it's also going to shift to the right too. So I'm going to make this a -1, then I'm going to add 2, which makes it 1, 1. All right, again, normally this graph would go through 4, 2. But again, I'm going to make that a -4. I'm going to add 2, which puts me at -2. And then that is enough of my graph to be able to see. And again, that looks like the same shape as your parent function, but it's been reflected and it has been shifted. If you weren't sure, again, pick those points, plug them in. Okay, if I did my table, if I plugged in 1, okay, this would be the square root of -1 plus 2, which is the square root of 1, which is 1. All right, if I plugged in -2, okay, the square root of negative 2 is a positive 2. So -2, 2 is that other point on my graph. Domain here, to the left, this graph actually doesn't stop, so it goes from -infinity, and then it stops once I get to 2. So I'd put a square bracket on 2. My range, the lowest to the bottom, is 0, and then it keeps on going to infinity. All right, so D, we're going to go ahead and skip for now because it's very similar to the graph we did previously, but if you need some extra practice, pause the video, try this one, and you can find your answer for that one on Schoology. The last thing I want to look at is actually writing these equations. All right, so I want to write the equation of a square root function that has been vertically stretched by 3, reflected over the x, and shifted up 6. All right, so what we're going to do here, actually, I meant to switch these, so I want this to be the y-axis. I want the next question to be the x-axis. All right, so if I'm going to take my square root parent function, right, reflecting over the y is going to change it left and right. So over the y means that I'm going to have a negative in my square root. Right? If it's been vertically stretched by 3, that's going to be outside the root. So that is going to be plus 6 on my stretch, or on my shift, and then times 3 on my stretch. Okay, so again, outside the root for both of these because they're vertical, but your stretch is being multiplied, your shift is being added. So plus 6 and times 3. And then finally, my last one. So I want to look at a function I already have. I'm going to shift it up 3, left 2, and reflect it over the x. So up 3 is going to affect the number outside. So that's going to change that to plus 5. Left 2 is going to change my inside. So this is going to become the cube root of x minus 1. Okay, because again, left 2 would be adding 2 to that point. And then reflecting over the x-axis would flip it up and down, so that negative would be outside. All right, so that is your new equation with those transformations. Now, the biggest thing I think to remember to this is you need to definitely be aware of what your new parent functions are. Okay, remember square root has this shape, cube root has this shape. Make sure you are familiar with your transformations because those are going to keep coming back up. And we're going to see them again when we do log and exponent graphs.